All right, in this one, we're going to convert a line formula into a condensed formula. So I'm going to kind of use a couple of different colors just so that you can kind of keep track of what's going on. So a lot of times you struggle with those line going to condensed because you don't know in a condensed what is a substituent and what's a main chain. But that part doesn't really matter. So when we look at this, you remember when we were writing those condensed formulas, that if you had methyl groups on the ends, that you could combine them in the condensed formulas. So I see that I have on this one a methyl group here and here, right? Coming off of is really this blue one is carbon 2, right? So this red one could be carbon 1, then this could be carbon 2, and then this would be a substituent. But it doesn't really matter what you call it. You just have 2 methyl groups on the end. So then I have another interior carbon, and then I have another 2 methyl groups right here and right here. So that's kind of important to recognize when you look at the structure, and it's going to make writing your condensed formula a whole lot easier. So we're going to start from the left. I'm going to do these 2 methyl groups first. They are both CH3. And I have 2 of them that are attached to the same carbon. So now I'm going to change the color because now I'm going to indicate this carbon right here. I'm going to call that one, right? How many hydrogens can be attached to that? Well, it's already got 3 bonds, so it can only make 1 more bond, so it's going to be CH. I go to the next carbon. That next carbon has 2 bonds attached to it, so it is going to make 2 bonds with hydrogen. Well, 2 hydrogen bonds. We go to the third blue carbon. That third blue carbon already has 3 bonds associated with it, so it can only bond to 1 hydrogen. And then that carbon is bound to 2 other methyl groups. So the 2 methyl groups are the ones in red. This is CH3, 2. So that's just kind of how to look at it. Is it kind of an interior carbon or is it an in carbon? So let's do the same thing. So I would color my N carbons one color. So we're going to do red. We're going to kind of stay consistent. And my interior carbons I'll do as blue. So if you look at this, it's the same sort of deal where you have methyl groups on the end. So we have 2 methyl groups on the end. So that's CH3, 2. They're both bound to that blue carbon, that first blue carbon. That first blue carbon has 3 bonds associated with it already, so it can only make 1 hydrogen bond. Then we go on to the next blue carbon, again has 3, so it's a CH. And then it has 2 methyl groups attached to it. Okay. And you can condense that further. You can condense that to CH3, 2, and then you have 2 CH. Then you have CH3, 2. Okay. All right. C. C is really pretty easy, right? You have these 2 methyl groups on the ends, and then everything else in the middle is exactly the same. All these blue ones are exactly the same. So in this case, I'd have a CH, a CH3, and then I have these blue carbons are all going to be the same because if you look at them, they all have 1, 2 bonds, 1, 2. They all have 2 bonds to other carbon molecules. So what we can do is we can just count how many we have. We have 4 of them. These are going to be CH2s. Oh, I miscounted. We have 5 of them. 5 of them. And then we have at the very end, the red one, which is CH3. And that's the most condensed you can get on that. Okay, so now in D, I still have those N carbons, right? I have an interior blue carbon here, but now I'm going to do this a little bit different color because I have a double bond. And if I have a double bond, I'm going to have a different number of hydrogens attached to it. So you got to kind of be careful, right? So let's start with the end. We have a CH3. Then we move into the blue. The blue has 2 bonds, so it can bond to 2 different hydrogens. So that makes it a CH2. Now these greens, count the bonds. There are 3 bonds around it. So the green ones can only make 1 hydrogen bond because they already have 3. So this is a CH and another CH. Now, a lot of times when you have a double bond or a triple bond, you don't combine them. You don't combine them like we did up here. You leave them so that you're indicating that there is a double bond or a triple bond there. And then red for the end, CH3. Okay. All right. I think then we need to go the other way. Let's see here. We're going to convert the condensed formula into our structural formula, right? The bottom one, B, is super easy, right? It's a straight chain. So all you would do was do 1, 2, 3, 4, 5, and then put all your bonds in, and anywhere you're not connecting a carbon, you put in a hydrogen, right? So it's all these hydrogens. Really easy. Okay, but then A is a little more complicated. So if we look at A, well, I have 1, 2, and then what is this CH3? The CH3 is a substituent, so I'm not going to count it in my main chain. Then I pick up on the CH for my main chain, then CH3 is a substituent. Then we have 4 and we have 5. And you can kind of look at the carbons and see how many hydrogens they have and know what the structure should look like. So I'm going to erase this one since I kind of need a room, since it's kind of a big molecule. Okay, so let's do this. So we have carbon. This one has 3 hydrogen and attached to a carbon. This carbon only has 1 hydrogen attached to it, and it's attached to the next carbon, but we know it also has this methyl group. So that's a carbon with 3 hydrogens attached to it, right? Okay, so we did carbon 1, we did carbon 2, we did the substituent. Now we're going to pick up on carbon 3. Carbon 3 has 1 hydrogen attached to it, and then it has a substituent. It is also a methyl group. So I put that in there. Great. Now, carbon 3 is also bonded to carbon 4. Carbon 4 has 2 hydrogens, and then carbon 5 has 3 hydrogens. And go in and add any hydrogens you need to. Okay. All right, let's see. I think we have one more kind of like that. So let's do A, because A is a little more complicated, right? So let's count them. 1, 2, 3. That's my main chain. Now, what's going to happen here is that I have a carbon that has a substituent of CH3. So it's carbon 3 is bound to carbon 2. It's bound to carbon, let's see, it's bound to carbon 4, which is going to be in here because we have 3 of them, right? It's going to go, we have 3 of them, so it's going to go 4, 5, 6 in the parent chain. Okay, and then we're going to have 7, and then we have a substituent, and then we have 8, and then we have 9. Okay, so let's do this. So we have carbon, it's got 3 hydrogens. Then carbon 2, we have 2 hydrogens, and it's bound to the next carbon. So this is all making sense so far. Now, when we get to 3, we only have 1 hydrogen. The other bond is going to be my substituent. That's a methyl group. Okay, so we did 1, we did 2, we did 3, we did my substituent. Okay, now carbon 3 is bound to carbon 4, right? Now carbon 4 is 2 hydrogens, 1, 2. Carbon 5 is 2 hydrogens. Carbon 6, 2 hydrogens. And I did that 3 times because of that superscript, that subscript of a 3. Okay, now carbon 7 only has 1 hydrogen attached to it. Carbon 7 also has a methyl group, well, I can't do CH3. I should draw it out. There's my methyl group. Then that carbon 7 is bound to carbon 8, which has 2 hydrogens, which is then bound to carbon 9, which has 3. So you just got to kind of count them and maybe check them off as you go, like I was doing. Any of those little strategies will help you to recognize what goes where. Okay, hope that helps.